Perfect. You did that just right. So then you're gonna practice a few more times.
These little moves right here.
You could keep graphing those if you want, but if you did this line right, where should they fall? Where would all these points fall? Because we could technically, in math, this line goes on forever. So if we did this whole line, if you were to check all these points, they should fall on that line. So you can double check your math by doing that. You can try that. Okay, good job, Shayla. Don't forget though, does this line, does it just stop at these 3 points right here?
Can I use like the red pen when I'm drawing?
Or you can use a colored pencil. Yeah, that's fine. Yeah, it goes on forever. And then a way you could check, where would this point, where would it be, where's the fast way we can know?
A little bit at the beginning.
Would it be on this line or would it be somewhere else on the graph?
I don't want to see the back of your head.
Yeah, all these points are going to fall on this exact same line. So that's the way you could check your math. Because you could be like, ooh, did I do it right? Let's see, is negative 2 8? Let's see. 1, 2, it's negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Right there. So you did it right. And then don't forget we always put arrows to indicate that the graph goes on forever. Good job, Jamal. How'd you get negative 6 for that one? We put in what's 2 times negative 2? Negative 4. And then if we added 2 to that, we have a negative 4 we're adding 2, so we're starting at negative 4. And then if we're doing a positive number, we're going to the right 2. So let's see, if I have negative 4, and I'm going to what about this? Did you want to work up on this number?
I'm not.
Oh!
So then you can see if you're at negative 4, and then I have to go positive 2, 1, 2.
Wait, no, yeah.
You could use this if you want to go over your number.
You do it on all of them.
I know.
On the little lines. Not just one
Negative 1, right? That's
I
good.
know, it comes back.
Good job. But don't forget, does this line just stop at these 2 points right here? When you're graphing, it goes on forever. With the arrows. And then you could also, sometimes if they were all on one, there were more than one graph on this line. You could write the equation right next to it, so then you know exactly what the graph
I just arrows for this. Now, where does 2 and Oh, I'm doing it on the
What does the line?
Yeah. And this is
That's the truth.
now do the next one. See? What do you do, right? Well, but I don't get how to do this. Nobody got this.
You can just write it right here.
So just like 1, 2.
Yeah, at the bottom.
Oh.
Ooh, you're on this problem. This isn't really actually real true. So it's saying, see this line right here? What is this line? Why are we putting this line here? The X and Y. But why just right here? Why didn't I put the line right here, here, like this? So what do these numbers mean? Putting them in here.
That one's
The Y and the X. These are all points. But why do we have these points? What do they mean? Coordinates. And they have to do with this equation.
Wait, is this one?
Like if I put in -3 and I got negative, and then using this formula, I got -10. What does that mean? What would be wrong if I had gotten -12?
You didn't do the right thing.
I didn't do the right one. So these are all the right ones. That's really interesting. So then when you graph them and you have this line, technically this line can go on forever. So what's neat about all the little points like
They're all like lines.
what's neat about anything that would be on this line?
They're lined up with each other.
What would they have to do with all these? They're the right equation, so it moves with the equation right. So would they be right answers or wrong answers for this? Right. So this whole line is saying that any tiny, I could even like this little point, I could get out like a ruler and find exactly what that is. Any point that's on here will make this equation a right answer. See, if I pick this point, that would give me a right answer for this equation. So only things on this whole line tell me everything that would work for this. So when you graph it, you can see that. So let's say I'm like, oh, it would work. Oh, let's see, this number would work. That would be negative. That would be 3, -2.
All of them have.
So if you went through and somehow you did the math, you can find that would be your right answer.
So it represents the right hand.
You represent all the possible answers that you could ever. This could go on to like a million both directions. It would tell you anything that would make this equation true. You have a question, Megan?
So when you're looking at the, what do you call it, the y-intercept, right? So it wouldn't count as crossing it if you're on the line. So if it's like 0, so like 0, 2, so it counts 0.
Yeah, because the y-intercept is where it crosses the whole y-axis.
So what if it was here on the line over here?
Would this be the y-axis? What axis is this? X. So that one we're just going so for this one we're just going to look at the y.
So it has to go to the y-axis.
Yeah, we're only looking for the ones where it's crossing the main line. You understand what you mean about it yet?
What?
Oh, so what would be the name of this point? How would you say this point? If you had to write it out.
This one?
Where it crosses the y-axis, that little dot. what's the ordered pair for that?
0, 2.
0, 2.
Oh, so it is crossing.
Yeah, that y-axis is where it crosses.
This one's 0, 2.